Hello viewers, welcome back. I'm Praveen. You're watching Module 4 of C++ Q&A. And in case if you have not watched Module 1, 2 and 3, then do watch them. So let's begin. So today's first question is, what is inheritance? Explain different types of inheritances. How inheritance is done in multiple base classes. Demonstrate. So let us first understand what is inheritance. What is inheritance? The technique of deriving a new class from an old one is called inheritance. The old class is referred to as the base class and the new class is referred to as a derived class or a base or subclass. Inheritance allows programmers to define a class in terms of another class. So in the new class, instead of writing the new data members and member functions all over again, they can simply just use whatever is actually defined in the base class. So here is the syntax. First you would write the class name and the derived class name. You will write class and the derived class name, and you would write visibility mode, like whether it's public, whether it's private or protected, and then you write the base class that you want to inherit or inherit. In a simple analogy, if at all we want to just compare and check with what is in a day-to-day language, then you can just you can define it like this. Derive quality and characteristics from parents or ancestors, like you inherit features of your parent. Example, you tell many a time she has inherited the beauty of her mother. So it's like you're inheriting some of the qualities of the parent or the base class in your derived class. Now, when a function is, when a class inherits the base class, so here like there is a faculty class and there is a student class. There is actually not a, you can't call it as a faculty class. Basically, you can tell it something like you have a person class and then you have a student class. So the person class inherits, the student class inherits everything about the person class. So he can actually, the data member, the method, some of which will be inherited in the student class. Now it's up to the student class whether he want to inherit, whether he want to use some of the methods or not. Okay, or he want to again derive and he want to actually override those particular methods and create or write their own function basically or own method. Now when you actually inherit, when a derived class inherits from the base class, there are certain rules. Like, so the visibility rules, what I'm talking about is the visibility rules. Now here I have again derived the class, derived class name, and then the visibility mode and the base class. So you have a class and you want to call it as a derived one or something like that. Is a derived one is a name. Then you tell what is the visibility. It's a public. Then you can tell which class you want to inherit. So you want to inherit class 1, and in private mode you want to inherit class 2. Now, what this visibility public and private means, I would explain to you that. When a base class is inherited as a public class in the derived class, the inherited derived class will be able to access all the public functions, all the public data members of the base class. All the public functions and even the protected ones, the public and the protected data members and the methods of the base class can be inherited or will here in the derived class. But if you inherit, if the visibility is protected, like if you tell protected class 1, then what happens is the derived class will only be able to inherit all the protected class members, and it will not be able to inherit the protected class member will be able to inherit both the public and the protected class. But what happens here is the derived class, even the public class, whichever are inherited by the derived class, will be visible henceforth like a protected class. So if there is another derived class which is derived from this derived class 1, then it is by default the public methods and the public functions will be protected. So they will not be able to directly access the public function because it's no more public, it's protected. Now as we are seeing here, if this base class, if the derived class inherits the base class as a private class, then it will be able to inherit all the public and the protected data members. But henceforth, so if any other class, if derived class 1 is again inherited and by a derived class 2, then that derived class 2 will not be able to access any of these public and the protected members. Naturally, private members are never inherited. So nowhere you see that private members are there. So private member by default are never inherited. Only the public and the protected members are inherited. And if you have actually if your derived class has a visibility of like a private, then the next derived class will not be able to access this particular even the public and the private member, because this public and the protected members have again also become private members, and the private members are actually not inheritable. So I hope it's very clear. Now these are the different types of inheritance. You can have a base class A and the derived class B. So it's a single inheritance. The derived class B is inheriting one base class, and that is called as a single inheritance. If there is one derived class and it is inheriting two base classes, then it is called as a multiple inheritance, because it is inheriting two multiple classes basically. And in case if there is one base class, but there are many derived classes which are actually inheriting the same base class, then it becomes a hierarchical inheritance. So you have a base class called class A, then class B, class C, class D, all these are inheriting class A, then it becomes a hierarchical inheritance. Now, if you have a class A as a base class and that is derived by the class B, so the derived class B is a derived class and it is inheriting the base class A, then you have another class C which is a derived class which is inheriting the derived class which is a base class as class B, so it becomes a multi-level inheritance. So class A is derived, class A is the class B is a derived class, and it is having a base class as class A. So the class C is having a base class as class B. So class B is inheriting class A and class C is inheriting class B. So naturally even it will be able to inheritance the class A also. But again, I told you the rules. This particular rules are going to apply this inheritance rules, how you are actually inheriting them. So if you are inheriting them as a public, then naturally it is like everything, whatever was visible to the class B will be visible to class C as well. But if you are inheriting that as a protected, then everything becomes protected, so only the public functions will also become protected. Now if you are inheriting as a private, then none of the variables can directly, or none of the data members or the methods can directly be accessed by the class C. Now this is a hybrid class. If class A is inherited by class B and class D, and both class B and class D are again inherited by class C, so it is something like a hierarchical inheritance at one stage, that is on the top of A has been inherited by class B and class C, so it becomes a hierarchical inheritance, and then it becomes a multiple inheritance for class C. It is inheriting class B and class C. So this is called as a hybrid inheritance. We'll see all this with some examples. So let me show you with some example. Okay, I think there is the next question basically is write a C++ program which uses the concept of simple inheritance. So they're all relating to the inheritance. So I will show you an example. I will demonstrate to you basically an example. So this is multiple inheritance. So I will actually start with a single inheritance. Now this is a single inheritance. So there is an employee class and you have a protected salary. Then there is a developers class, and in the developers class you have a function called salary. And this function salary, which is in a public, here you are actually accessing the protected member directly of the base class. So you can just see here, this is an employee class which is a base class. The class developer is a derived class. And it is accessing it as a, so we will first access it as a, it doesn't matter what you access it as, it is because this particular, this will be able to access everything, and like the next object, the next class will not be able to access it. So let me write it anything, doesn't matter. I will show you with both public and, so here I wrote public. So in the main class we are creating an object of the developers class basically. So the developers class is this. We are creating an object of the developers class, and then what we do is we are calling the function salary, and this salary function is in turn calling the data member of the base class. Let us see it works. Let us see whether it compiles. So let me compile this. Yes, it's compiling, and let me execute this. Build and execute. So it is telling enter the salary. So let me enter something. Okay, so I entered a salary. and you can see it is displayed the salary. So we are able to access this variable if whether we inherit as a public or as a protected, it should not make any difference to the very immediate class. So let me show you that basically. So now I am inheriting as a protected. It's successfully, and again the same thing. So it's actually working properly. We can also do it like a private. Even though we are inheriting as a private, we should not have any problem. It's compiling properly. Okay, and we can execute. So you can see it's working properly. No, this is actually a single inheritance. Now I'll show you an example where you will have a multiple inheritance. Or see, here I've created already an example called multiple inheritance, and it's the same again. Here we have an employee class, and we have a same developers class. The developer class where we are inheriting as a protected, and then we have another class called niche developer. The niche developers class is also trying to access the same variable directly, the salary variable from the base class. Now let us see whether it actually compiles and whether it works. So we are creating now the object directly of the niche variable, and we want to access from the niche variable, that is the multi-level inheritance. Okay, so let me show you it in the diagram what we are exactly doing here. We are doing this multi-level, the class A, class B, class C, something of that kind. Okay, so we are doing a multi-level. So here we have a employee class which is inherited by the developer, and the niche developer inherits the developer. Now let us try to compile this. We compile, it is compiling properly. We build it, and let us see whether we can execute. So we are executing. So you see we are able to access this particular variable, salary variable, directly from the multi-level, that is second level derived class basically. But had we actually inherited this as a private, then here it is not a problem, but this particular derived class will not be able to inherit that. So let us check that whether it is true. So if we inherit it as a private and then try to compile this, then you see an error. You can check that. So we are seeing so many errors there. Actually it's one error. In function niche salary, the class employee is inaccessible. You can just see here it's written as a inaccessible. Okay, I can show you something like that. So it is inaccessible. So what do we do? I hope you have understood very clearly that if you are, I'm exactly trying to explain to you this particular one. Okay, so now we are actually trying to, we have inherited as a private. So you cannot have a multi-level. You cannot, the next derived class will not be able to access it. So if at all we actually, in case of niche developer, if we have a private, and this I have already shown you here. So if you have a private also, it is actually, and we have created an object, you can access it. But if you have a private, here you can see, if you create a private developer, then the next niche developer will not be able to access this. Even if you make it public, it doesn't make it any difference whether you make it public or private. It doesn't make a difference. It's all the same. It is going to still have that error. It will not be able to access this salary from the parent base class. So I hope it's very clear how this is working. You want me to we have already executed and checked this, so you can make it public, and it compiles and execute. So you can see this, it's working. Now here I have another example. This is again single inheritance, which I will already explain to you. I have another example here, multiple inheritance. So let us go back to let us check what is multiple inheritance. So this is a multiple inheritance. The class C is actually inheriting two base class A and class B. Something of this kind is what I'm trying to explain to you now. So we have a student class, and we have another class called extra curriculum class, and the output class basically inherits the student class as well as the extracurricular class. Now the student class is having three data members, that is roll number, M1 and M2. This is protected. So if it is protected, only the derived class can use this, and this cannot be accessed from the main function or outside the base class or the derived class. So outside this base and the derived class, it cannot be accessed if it is protected. So the public is a function which can be accessed from anywhere. Now this extracurricular class is another class. So one is a student class, it's having three variables. The extracurricular is having one variable, xm. Then this particular output class, it's having its own two variables, that is total and average. And it's having a method called display. The display method is accessing directly M1, M2 from the students class and xm from the extracurricular class and making it as a total. And the total is divided by 3 and it's made as an average. So we are making an object of the output class only directly. So we are not accessing any of the base classes. We are accessing only the final output derived class. So object O is created and O.get. So O.get is actually trying to get the data. It is accessing the public method from the parent base class. Then one of the parent base class. Then O.getSM, this is from the other parent base class, that is extracurriculum, that is getSM. It is accessing this one, and the display, it is accessing from the derived class display function. And here again in the derived class, we are accessing the variables and we are displaying the variables. So let us see how it works, whether it compiles or not compiles. So let us compile this. Yes, it is compiling properly, and let us see the answers. Execute. So enter the roll number. So I enter it as 5 and enter the highest marks of 2 subjects basically. So I enter one as 98 and the other one as 95. Enter the marks for extracurricular activities. So we enter that as a 90. So the roll number is 5. All these marks, if they are added 98, 95 and 90, it becomes 283. The average is 94. So you see it is able to access the data members of the derived class, is able to access the data members of both the base class. So I hope it's very clear. Let us go to the next question. So you have write a C++ program which uses the concept of simple inheritance, which I have already explained to you. The next one is, what is a file? Explain file open and close functions with arguments. So Kate will understand about what is file basically. So what is a file? First let us understand that. When a large amount of data is to be handled in such a situations, floppy disk or a hard disk are needed to store the data. So everything cannot be just stored in the RAM. If it's a large amount of data, if you want a persistent data, you want to store the data for even after putting off and on the system and all that. You want a persistent data, you have to store it into the floppy disk or your hard disk or your pen drive, something like that. The data is stored in these devices using a concept called files. So a file is a collection of related data stored in a particular area on a disk. Program can be designed to perform read and write operations on these files. The I/O system of C++ handles file operations. So it is automatically handled by the I/O system of C++. It uses file stream as an interface between the program and the file. So there are file streams, like how you have I/O stream, you have a file streams. So the file stream acts as an interface between the program and the files. The stream that supplies data to the program is called input stream. So if you are reading something from the file, it is an input stream, and one that writes data from the program is called as an output stream. So here again I am trying to explain the input and output with a diagram. So this is your program and this is a disk. Now when the program reads the data from the disk, it is actually the input stream. So it's a input stream, reads data from the disk, it is called as an input stream, and when it writes data to the disk, it is called as output stream, and there is an output stream function which takes care of that. So the input operation involves the creation of input stream and linking it with the program and the input file. So what exactly we will have to do is, the input stream we will have to create, and we will have to give the program, open the program and link that particular file to the input stream. So once you open it with the input stream, it will take care of reading from the file, and if you are opening it in the output stream, then it will write to the file. So I will show you with an example. Okay, so here we have the details about the streams. File input streams reads data from disk file to the program. So what input stream does, it reads data from disk file to the program. So the program reads data from the file. The output streams, the program writes data to the file. So I/O operations of C++. So in case if you have to do input, you will have to include the header file if stream and if you want to do output, then you will have to include the header file OFStream. The function for opening and closing of the files is open, to create a file as well as open an existing file, and close, to close an existing file. So I have an program. I will explain to you that. So this is a file handling program, and here you can see I have done both OFStream. So as I was explaining to you, you have to use OFStream, and this is a file name. Sorry, this is the name we are giving to the stream. So that is my file. Now my file will be used for all read and write operations, and here we are giving inside the bracket the name of the file that we want to open. Okay, so we are opening in the output stream. So when we are opening in the output stream, it means we want to write to the file first. So we are opening the file example.txt, then we are writing, this is the line, this is another line, and then we are closing the file. Then using IFStream, here we used OFStream, here we are using IFStream, and we are opening the file again by another name called myfile1. The same example.txt, we can open it because we have already closed the file, so not a problem if you open again. If it is not closed, then you cannot open it. Okay, and then you can basically, we are reading till the end of the file. Okay, if as long as it is receiving some data, it is receiving, while get line is true, we are going on printing that each line. So let us see now, if we run this program, what should it do? Basically, when you run this program, this is totally, it is written in the main file itself. So when you run the program, what it basically is going to do is, it's going to write these two lines. It's going to close the file. It's going to open the file here, and it's going to print these files. So we will be able to see on the screen this is a line and this is another line. So because here we have used cout to display whatever is there in the file when we open it next time in the input mode. So let us run this program. So compile, build, and execute. So you see, you can see this is a line and this is another line. So you can see there are two lines printed. I can add another line. So beautiful city, then I can print this. You can print this as well. So let us see, compile, build, and execute. So we are writing the third line as well to the file, and we are able to print that. So it's clear. We will again go in more detail in the coming sections in the files. So next question is how the concept of polymorphism is incorporated in C++. Explain with example. So let us first check what is polymorphism. I think I have already explained to you what is polymorphism. Okay, but I wanted to execute a program of a function overloading. Basically, operator overloading we have already done, and let us do a function overloading. So what is polymorphism? A polymorphism means ability to take many forms. Polymorphism means having many forms. Okay, anything. It's like you're using a different, you can have many forms basically. Now polymorphism are again of two types basically. That is, one is compile time. So at the time of compiling itself, the compiler knows whether it's a function overloading or whether it's operator overloading. Those functions are created. The other one is a virtual function, wherein in virtual function what happens is the compiler does not know. Okay, we will get in more details. The compiler does not know at the compile time which is the function it has to execute. Okay, so this is at runtime it makes the decision. So this is a compile time, that is function overloading and the operator overloading. Now we have already seen this function overloading. What is function overloading? When there are multiple functions with same name but different parameters, then these functions are said to be overloaded. Functions can be overloaded by change in number of arguments and or change in type of arguments. So I have explained to you this earlier, that you have a function, three type of function, and each one of them are having a different arguments in them. Okay, the first one is having only integer as an argument, the second one is having a double as an argument, the third one is having two integers as argument. So let me show you this with one example. Okay, so here we have a function overloading program. So what is this doing? We have one integer, the next one is a double, the third one is a character string. Now when we are actually printing 10, so all this actually what these functions are doing, what this data members functions are basically methods are doing is, the first method is actually having only integer as a, so this integer when it is given as a, it will print that integer. So if the value that is given is integer, it is automatically calls this one. And if the print is having a double or if it's a float value, then it is automatically calls this particular second function. And when it is having a string, it automatically calls the third one. Now if the string one calls the first one, it will be an error actually. So it is definitely calling all the functions properly. So let us execute this one and check whether it does the work. So we have the function overloaded, the print function is overloaded with integer, print function is overloaded with double here, and print function is overloaded with the character string. And here we are calling the print 10, print 10.10, and then print a string. Let us execute this. Okay, some warning. No, okay, it's only warning. So you can see it is here is a int, this here is int, here is float, whatever value we gave it as printing, and here is a character string, that is 10 is written and 10 is just displaying. So I hope it's clear what is function overloading. So the next question is, what is virtual function? How is it different from the pure virtual functions? Now for that we will have to first understand what is virtual function basically. Then we will see how is it different from the pure virtual function. We will understand pure virtual function and we will then see what is the difference between the virtual and the pure virtual functions. So what is a virtual function? A virtual function is a member function which is declared within the base class and is redefined, overridden by derived class. So when you refer to the derived class objects using a pointer or a reference to the base class, you can call a virtual function for that object and execute the derived class version of the function. I'll explain to you what exactly it is. So let us actually read this. Virtual functions ensures that the correct function is called for an object, and regardless of the type of reference. Now this itself, I think it should make you explain that you have a base class and you have a function declared in the base class. The same function is again declared in the derived class. Now you have a multiple base classes. Okay, so multiple derived classes. So it is like this. I will tell you. Let's go back to that particular. So it's something like a hierarchical inheritance, something like this. So you have a base class. You are actually having class B, class C, class D. All three of them are inheriting this particular. So I think are inheriting the same class A. Now when all three are actually having their own derived class, they are overriding the class A. So they are having the same method again and again declared, and they are declaring and they are executing. It's having a different function basically. So it is doing a different function, but they are having the same method. So if you are using a pointer and accessing this particular a pointer with the class A, then you will be able to actually move between these B, C, D and be able to print the value or execute the variable function of this particular class B, class C, class D. I'll show you with the example, but I wanted to show you. I hope it's clear. It's a hierarchical inheritance, and exactly when you are using in this format, this is where the virtual function actually becomes useful. So virtual function ensures that the correct function is called for an object. So because this is having a three derived classes from one base class, regardless of the reference type, it is able to call the correct function, virtual function. They have used to achieve run, but this can happen because this doesn't know. Now let me show you with an example basically. Then you would understand virtual function, and we have a base class. This is a base class, and this base class there is a derived class here. Now this derived class is having the function. This is called function called, see, and this is base class function is called. Now if it's not a virtual function, first let us check that. If it's not a virtual function, then what is going to happen? It is compiled. Now let us look at the main function first, and then so you have a base, you are making a pointer to the base class, and so that you can refer the derived class to the base class, and then you are executing the function func. Now this function func is function fun is there in both derived and the base class. Now which is it going to execute? Because this is a base class and it is referring to the derived class. So let us check that, then you will come to know what is happening. Now what has happened? Just see. It's telling this function of the base class is called. Now though we are referring to the derived class, the derived class is not getting overridden basically. It is simply calling, because it's a base class, the B is of the base class, and whenever you are calling the function fun, it is actually calling the method from the base class. Now if you have something, another derived class like derived class 1, derived class 2, derived class 3, then it's going to be difficult in this case. So if you have a derived class, then it will still be executing only the function 1 from the base class. So you want to execute the function from the derived class, then what you will have to write is virtual. So if you write virtual, now what will happen is, if you compile this, now you can see fun is called, and this fun we have written it in the derived class. Now I can show you with here, this is derived 1, we will call it as. Okay. And I will make another class called derived 2. We'll call this as a derived 1. And we'll make another called derived 2. And if you have one derived 1, then you actually refer to this to the derived 2. So you can actually, the greatest advantage is, like you can have any number of derived classes, and you just you are created one object of the base class, a pointer object, and it can refer to different derived classes and execute the functions of the derived classes. That's the greatest advantage of using this virtual functions. Let me compile this. Okay, this I've given as number 1 here. So that's why the error is. Okay, so it's all coming in one line. Let me put /n there so that you come to know which one is getting executed properly. And let me not print this one. And we can actually print the base class as well. So if at all we can actually print the base class value also. So let me do this. Okay, let me not execute this. I think I didn't build it, sorry. Okay, so now I built it. So you can see now it is calling the derived class 1 and derived class 2. Okay, so it is able to call a different function based on, you are able to give, just because it's created a pointer of that class, you will be able to access the different derived classes. So this is a virtual function. So the virtual function ensures that the correct function is called for an object regardless of the type of reference. So you can have a reference to derived 1, derived 2 and all that used for the function. They are mainly used to achieve runtime. So at the runtime it is able to know whether it has to call the derived 1 or the derived 2. Functions are declared with a virtual keyboard in the base class. So that is what we have done. We declared the function using the virtual keyword. The resolving of the function is done at the runtime. So what is that actually? They must be declared in the public section of the class. Now these are some of the conditions for the virtual functions to be. It should be declared in the public section of the class. The virtual function cannot be static and cannot be a friend function of another class. So the virtual function cannot be a static, cannot be a friend function of another class. Virtual function should be accessed using pointers or references of base class type to achieve runtime polymorphism. So it should be accessed using a reference or the pointers, which we have already seen. We have created a pointer and we are using a reference, basically using a pointer. The prototype of the virtual function should be same in the base as well as the derived class. So we have actually have the same prototype. We are not changing the prototype of the function. So I have shown you, I have executed and show you. Now let us understand what is a pure virtual function. Now the virtual function are actually, you have the function which is already having all the details in the base class, and you can also override it in the derived class. But in the pure virtual function, you do not have the definition in the base class. So the derived class has to compulsorily override and has to compulsorily define that particular function. So let us read this, understand, and virtual functions are definitely defined in the base class and refined in the derived class. On the other hand, pure virtual function, the base class is particularly not defined in the base class. So it is the virtual function that in the base class, the function is not the detail of the function is not defined. The body of the function is you only define the function. Derived class, if required, redefines the virtual function, whereas in case of pure virtual function, derived class has to definitely redefine the pure virtual function. So it has, because the data is not there. The function is not defined at all. Okay, only the declaration is there. So you will definitely have to define it in the derived class. If the derived class fails to redefine, if the derived class fails to redefine the virtual function, it can use the virtual function of the base class. On the other hand, if derived class fails to override pure virtual function, then compilation error occurs. So if the derived class fails to override pure virtual function, there is a compilation. So you cannot override. If you cannot fail to override a pure virtual function. So base class containing the virtual function can be instantiated. That is, the object can be created, but the base class containing pure virtual function, that is abstract class, cannot be instantiated as a abstract class, is not fully defined. So directly to tell you a base class itself, you can create an object of the base class itself in the virtual function, but in pure virtual function you cannot create an object of the base class, because the function is abstract. Basically, you do not have the definition of the function. So pure virtual function, it has no definition in the base class. Pure virtual function is declared as, so it is declared as something like virtual, okay, the return type and the function name and the function argument, and equal to 0, and you close it. So that's all. You're just not defining, you're not giving any body of the function. Basically there is no body of the, only the declaration of the function is there. So it is virtual return type, then what is a function name, and then you have a function argument equal to 0. All derived class must override pure virtual functions. Gives compilation error if derived class are not inherited. So if derived class, if the pure virtual function does not have a derived class, then it is, if it is not inherited, or if you do not have a derived class, it gives you cannot instantiate, you cannot create an object of the base class. So it gives a compilation error. If class is pure virtual function, then the class is declared as an abstract. So actually an abstract class. So let me show you a pure virtual function. So here we have a base class, a function, a base class, class base. It's a normal class. It's having one data member called X, and it's having a virtual function. Now this is a pure virtual function, that is virtual void, then you have a function name fun, and it is equal to 0. That's all. There is no body of the function. So what we have to do is we will have to have this a function in the derived class. So this derived class is actually inheriting the base class, and we have a function same name fun here, and we are outputting cout fun called. So here we are creating an object of the derived class, and we are calling the function from the derived class. Naturally it only calls from the derived class, and it returns 0. So let us execute this. Let us compile this. It's compiled successfully. Build it and execute. So it has executed. You call the function called. So it is called. Now in case if we had not defined the function in the derived class, and we may not even call it, let us see what happens now. So it gives an error. It is giving an error. You cannot declare variable d to be an x because it's using an abstract, and it has to have the function to be declared. Now in case if you do not want, can we create an object of the base class directly? Can we create an object of the base class? Let us see whether we can do that. Base b I will call. We'll create an object and b dot fun, and let us try to compile this. No, we cannot. So what is exactly? Cannot declare variable b to be of the, because of a abstract type base. So base type is an abstract, and that's why we cannot create a variable, or we cannot create an object of the base class. So I hope it is very, very clear what is pure virtual function. In the pure virtual function, you have the base class defined as virtual, and it's just a declaration of the function, and that too it's just a declaration of function and equal to 0, and you close it, and the body of the function is actually defined in the derived class. That is a pure virtual function. So I am very sure it's very, very clear to you. The next question is, explain this pointer used in function of a class. What is this pointer? This pointer is a constant pointer that holds the memory address of the current objects. Now whenever you are actually calling, if you have a class and it is having a function and whose variables are again having the same name that of the object, data member of the object, then there is a clash of, I'll show you with, probably I'll write one like program in the next time, I will show you this. So this pointer is a constant pointer that holds the memory address of the current object. This pointer is passed as a hidden argument to all non-static member functions calls, and is available as a local variable within the body of all non-static functions. I'll show you with one of the example whatever we have done now till now. Okay, we'll use the same thing. Now we have one variable in the derived class called y. Okay, we want to access this particular variable. Now if I have this function integer y, and so I'll create one constructor and assign some value to this y. So y is equal to something like 1. Now we will call another function okay, let us keep this for displaying, and we'll call one function called input. And I will call it as integer y, and then we'll call it as y is equal to, we just because this is y, okay, y is equal to y. And then let us see what happens now when we will try to print this in function y. We will try to print this y. Now what will happen? Let us check it ourselves. So we derive, and it's p1. I will have to call this input function. So we created a variable called to be d dot input, and then I want to give the value 10. Now what is going to be printed? Let us see. It's compiled successfully. So it is printing 1, basically because I didn't keep a space here. So its value of y is 1. Though I gave a 10 as a value, it's still the value of y is 1. So if you want to use the actual object, the default address, you can use this operator. Now if what will happen is, if you compile this again, okay, and so now what has happened? Value of y is 10. So it has assigned 10. Now this actual variable 10, the data member of this particular class, is got assigned the value. So I hope it's very, very clear. I've written a program for you and immediately shown you this one. So this pointer is passed as a hidden argument to all the non-static members. So this pointer is a constant pointer that holds the memory of the current objects. So if it holds the memory of the memory address of the current object. Now another thing that I want to tell you is about the scope resolution operator. Now this is one which actually I've shown you some examples. I've written directly the function inside the base class so that you could understand more comfortably and easily. But at the same time, I also want you to understand the scope resolution example. I will show you with an example and make you understand it. So scope resolution operator in C++ to access a global variable when there is a local variable with the same name. So there are four conditions in which you will have a scope resolution operator. To access a global variable when there is a local variable with the same name. Now example, let us actually we have executed this program. Now we want to use a global variable with the same name. So we have something like this. Now you want to access, you want to store the value into this one basically. So now we are accessing that particular global variable, and we will be printing the global variable. Let us check this whether it's working fine. So yeah, but how do you know it's a global variable? Okay, that is so what we will have to do for that is, okay, let us do one thing. We'll have one more function here, because otherwise you will not be able to know. So we'll call this so when we call input, and we'll have another one here called input 1, and we will also print both okay. So I will have to call this one again, but with 1, and I'll call this as a 99. Now let us see. So what I have done is I've created this in the input. We are actually storing the value into the data member of the class, and in the input 1 I'm storing the value into the global. So I've used a scope resolution operator and y. So when you use scope resolution operator, the value will be stored in this y. Okay, and when you use this operator, it will be storing the value into this y, and if you don't use this, it will store the value into this y itself here. So that is the difference. Now what we are trying when we call the function, what we are printing all of them, and we are printing first we're just printing y. So y is going to be printing this y, that is the data member of this particular derived class, and here it's going to print the value of the global. So let us check, and here we are calling, so we are storing 99 into the global. Let us see whether it's exactly doing that what we intended to do. So you can just see value of local y is 10 and value of global y is 99. So exactly how I have told you, exactly like that it is storing. So to access a global variable when there is a local variable with the same name, to define a function outside a class. Now let me show you the second one, to define a function outside a class. Basically yesterday when I was actually explaining to you scope resolution operator overloading, and I wrote that function inside I will try to open that particular function, but I will explain to you first what exactly it is. Now you have this function input, okay, and what you want to do is you want to write the body of this function, that is this one, or we have this function fun. We want to write this body of this function outside the class. Now, if the functions are very big, naturally you cannot write all of them inside the class itself. So you would want a extra space, and here what we do is inside the class we only declare the function, and we will come outside the body of the class and we will actually give the definition. We will give the complete function. So in that case, what we do is we put once. So I will just copy this first. And you don't write this body of the function, and you just put a semicolon here. Now what you have to do here is you would have to use the scope resolution operator, telling it which function you want it to be called. So successfully compiled, build and executed. So it's doing this exactly. So what I did is, if at all you are using a function here like this, now I've written the body of this function outside. So I will try to open the yesterday's program which I actually showed you. So this is operator overloading. Now this function, if you compile it and we executed this operator overloading, it is actually what this function it is doing is, we created an object called C, we created C1, C2 and then C3, and I explained to you that it is storing the value of C1 and C2, adding both them, and it's storing the value into C3. Now this is, I explained to you, this is a return type and this is an operator. You would have to write it's a keyword to be used whenever you are using operator overloading, and you will have to define which operator you want to use, whether plus, minus, whatever it is. You write it here, and then what is an object you want to supply. So I told it very clear that this A actually is the function of, like, if it is C1 is actually calling this, so the A is a value of C1, and this object A, the value that is come with this, the object A is the value of this C2. Now all this is okay. This is the same thing what I have explained to you. Now what is exactly what I want to show you is, if you are writing the function outside this, now that is what you would see in most of the books basically. That's why I'm trying to explain to you this one. What you would see is, you would not find this, and you will only find it here like this. And then it's a return type, then you tell the class. So okay, sorry, this one arrows remain more there. So it is successfully compiled, and we'll build this and execute. It is doing. Yesterday I showed you this program and it's working fine. So this is the scope resolution operator. So if at all you are writing the function outside, you will have to tell which class this function belongs to. That is exactly what, here is a return type, and this is which class it belongs to, and then you write your normal function. So this is what I showed you just now also. to access the class static variable. Now to access a class static variable is like if you are accessing a static variable is actually if you are declaring any variable as a static variable in your function, then actually what happens is you may have any number of objects, but you will only have that variable as one. So even if you have 10 objects, then all the 10 objects will have only one variable. So if one of the object changes the value, then all the 10 objects that particular value is changing, because it's only creating only one variable for that particular. So if you are having a static variable, and to access a static variable, you will have to use to access a class static variable, you will have to use a scope resolution operator. And in case of multiple inheritance, now in multiple inheritance, you would not know. It's because to tell you in multiple inheritance you want to use you want to know, like you have the base. I'll show you with the diagram so you would understand what is actually multiple inheritance. Then I can actually show you with this. Okay, so this is multiple inheritance, and what happens is class A you have and class B, and you have a class C. Now there may be a function of the same name in the class A, and in the same name in the class B, and in same name in the class C. So if you want to access the function of the class A, then you can use a scope resolution operator and tell it, okay, go and execute the function of the class A. And you can, if you are using the function of the class B, then you can use the scope resolution operator and tell, okay, you execute the function of the class B. So that is for that you would be using the next one. So this was not there in the question, but I particularly wanted to make it clear to you, and that's why I added the scope resolution operators in C++. I hope you have understood it very clearly. So I hope you have enjoyed learning this. So if you have enjoyed, please like, share and subscribe our channel. Thank you very much for watching.